All right, you masters, what I'm going to have you do is try some problems that you're going to end up helping the others with today. You're going to be my master tutors. What I'd like you to do on your paper that I'm giving you, I'd like you to try this problem first before you just copy the work on your paper. I want to see that you have true masters, because remember, for you to teach someone else, you really need to know your stuff. So try these first before you just copy the work. And then when we're ready, I'm going to have you help the other students at some point with these problems. Help them out. All right, here we go. So this first one, hopefully you gave it a try first, but I want you to plot the y-intercept first on the y-axis, or the up or down line first, and then use that rate of change or slope in front of x as rise over run to get additional points from your starting y-intercept. So starting at -1, my very first point, then from there, looking at my rise over run, I'm going over a box and then up 4 before I put my next point. Over a box, up 4. Over a box, up 4. Stair step the opposite way. Instead of right 1 up 4, left 1 down 4. Left 1 down 4. Still equivalent slope 4, but stair step in the other way. Make sure you label your line. And then graphing the second one with that y-intercept. So again, graph it, label your line for these systems. All right, last one has you start at 1 on the y-axis, or the up or down f of x axis, and then from there, using that 2 as a rise over run, number 2 over 1, remember any whole number over 1, start at 1, over 1 box, up 2. You can see they intersect already. Over 1, up 2, right away they're touching. Over 1, up 2, over 1, up 2, over 1, up 2. Stair step the opposite way, down 2, left 1, or left 1, down 2, left 1, down 2. Still equivalent slope of 2. I want you to clearly label that line again. And then I want you to check this one. Label that point where they intersect. This coordinate is over 1, up 3. So that's the coordinate 1, 3. 1 for x, 3 for y, or 1 for x, 3 for f of x, which is kind of like y. It is y. So that is the coordinate where they intersect. I'm going to have you check it by plugging in that 3 for f of x and 1 for x into both of these. So for the check, here I go. So for the back equation, 4x minus 1, I'm going to replace that f of x with 3, and then equal, and then I'm going to write that as 4 and plug in my number for x right there, 1. So there's the f of x number, there's the x number from that coordinate. So that gives me 3 equals 4 minus 1, which is a true statement. And then when I check my second one, f of x equals 2x plus 1, plugging in 3 for f of x and 1 for x. Gives me another true statement. That gives me 3 equals 2 plus 1, which is 3 equals 3. That is another true statement. Have them do their check. Have them graph it. Have them label the lines. Label the point. Check for that, tutors. Show me that you're worthy of this X credit. All right, next problem, substitution. For this one, again, show them that you're taking this equation and substituting into the other one's f of x. Since these are both equal, I could write f of x here, or since these are both equal, I could write this here, since they're equal. So I'm going to substitute that piece in and do a little algebraic trick. So that f of x gets replaced with this 4x minus 1. The rest is the same, that equal, the 2x, the plus, the 1. The only thing that got changed was this piece right here. And then it becomes of variables on both sides, where you start on the left side by getting rid of the plain number by doing the opposite of it on both sides. Bring down everything else. 4x equal 2x. This gives me positive 2. Stay on this side of the equation and eliminate the 2x term. Minus 2x. Minus 2x. Bring down 4x minus 2x, which is 2x. Bring down the equal, bring down the 2, and then just divide both sides by 2 right there. Third step on the left, divide, and that gives me half of my answer, half the coordinate. X equals 1. So again, make sure you don't stop there. Make sure you write that number in the right place for the coordinate. And then to find the last piece, which is really y, or now f of x, take that x and plug it into either of the equations for the x piece. So follow the green arrow, plug it in right there, or I could use the black one and plug that 1 right there. I'm going to use the first one. So that gives me the function at the first term. That's what this means. That means I'm plugging in x as 1, or the first term in the sequence is 4 times 1 minus 1, or f of 1 gives me 4 minus 1 gives me 3, or the function evaluated at 1 spits out 3, or the first term in the sequence 1, the y number or f of x number is 3, or the input is 1, the output is 3, which we're going to start looking at input output in terms of functions. So put that 3 right here for f of x, and then check it only optional. Plug in 3 here, plug in 1 there. I'll give you a true statement. 3 here, 1 here. So optional check. All right. Next is the elimination method. Just make sure when you're helping your people with this, tell them that it's the different one where you got to rearrange them a little bit first. They're not ready to plug in or graph right away. You need to do something to them first. So the first step is to get the 4x on the other side with the f of x. So take away 4x on both sides. This goes away. This gives me negative 4x plus f of x equals negative 1. I got to make sure I write that negative 1. Take away 2x right here, gives me negative 2x plus f of x equals 1. Be careful. And again, I see that mistake right there. That should be negative 1. I will fix this eventually. And then I need you to stack them on top of each other and then do the math to eliminate the f of x term. So negative 4x plus f of x equals negative 1, which I'll change here shortly. That is negative 1. And on the bottom, negative 2x plus f of x equals 1. So again, I'm going to change that. I'm going to erase that. Make that negative 1, so be careful. And then again, the way these are set up with that negative 4x plus 4fx equal negative 1, nothing goes away. I want this f of x term to cancel away, so I'm only solving for x. So I'm always going to multiply one row by negative 1 and make sure I distribute that negative 1 all the way through, a triple distribute. Negative 1 times this, negative 1, negative 1, all the way down. I'm going to rewrite it, write it again after that little step right there, so it's nice and clear to see. So I'll have 4x negative f of x equal positive 1 right there, and on the bottom negative 2x plus f of x equals 1. And now when I add straight down, I get 2x, I get the f of x's going away, or the y's canceling out. Really, there's no more y's. So I have 2x equals 2. And then when I divide by 2, that gives me x equals 1, the same answer as all the other methods I've given me for 1. And then I'm going to take that and plug it in. Now I have more options. I could plug it into either these two or these equivalent ones that look different but are technically the same, equivalent. So again, I could take that 1 and plug it into x into either the original ones or these equivalent ones that look different but are exactly the same. They're just equivalent. They look different but they are the same. They will give you the same number. I'm going to choose this original blue f of x1 this time. So when I evaluate this blue function here for 1, I'm evaluating this function for 1, or I'm plugging in 1 for x, or the first term in the sequence is 2 times 1 plus 1. Gives me the first term in the sequence is 3, or when I plug in 1, I get 3, or the input is 1, the output is 3, or the coordinate I plot is 1 for x, 3 for y, or 1 for x, 3 for f of x. All right, hopefully this is giving you the skills and tools to help the people. If you have extra time, the majority of my students did not do last night's homework, so if you could go to the class document and click on right away the Desmos link, maybe watch the instruction link if you want, but click on the Desmos link right away and then just go ahead and join. And then I want you to try these 4 problems, or these, I think there's 6 problems. This first one has you put the point in the right place. It has you look at some people's answers that they've already put in. I have proof on my screen how many problems that you do. To get full credit, you got to do all 6. So good luck with that.